Okay, guys, good morning, and I'm going to quickly take you through how to go about this task. So what we are supposed to do is write pseudocode and design flowcharts to kind of give a different perspective to our coding ideas. So here, largely, you are not supposed to write any code. You are just supposed to write pseudocode and then create a flowchart of your pseudocode to explain to a layperson, someone who is not a programmer. So we are not going to be using programming jargons here. So what we do here is so the key thing is to go through the concepts, the resources we have here, and then for task 1, being a square keeps you from going around in circles. Calculate the sum of squares of given input numbers. So we are supposed to write pseudocode for this project and then create a flowchart. That is why it's always create the algorithm in a flowchart, save a screenshot and upload to a Google Drive and give access to anyone with the link. Okay, so what I have done is go through the projects one by one. So I'm going to show you one now. Good. So this is the pseudocode for the sum of squares giving input of numbers. So I will start, and then let's say we have the numbers there, so read the numbers and initialize the sum and the number count, which is here. Then I'm going to find the square of each number, and that is n equal to I times I. That is just like I squared. Then you print the result. Now we have to repeat these steps for all the numbers until we reach the last given number, and then we now put together the sum of the various results. So the squares for each number, we add them together and print the sum to end our program. So that is the pseudocode for the algorithm. So if you look at it, it's just how you have an idea. You want to create a program that will calculate the sum of squares of given input numbers. How are you going to go about it? Write it in a layman's language. So you can use something like this. This is my idea of how to go about it when it comes to writing pseudocode. Now, if you look at the examples in the flowchart, I have sum of squares here. So let me zoom in. That's too much, so that we see what I am talking about. So over here, sorry. Okay, so here we are with the flowchart diagram. So I want to be able to always know that your flowchart must have a start and an end. So the first step is to read the numbers and then initialize the numbers. So I'm going to initialize my sum to 0 and then the given numbers to 0. I currently don't have anything. So if you go up, that is, you see that I've loop through the numbers. So I'm going to loop through the values for n. So we have n equal to I by I, n equal to I by I, till I reach the last number in that series, and always print the results. So n result 1, n result 2, n result 3, 4, 5, 6. And then the next step is to sum all these results, because that is the squares of the various digits you were calculating the squares for. So res1, res2, you sum it, and when you sum, you now display the sum, and this will now end your program. So that is the flowchart for the sum of squares, and I've already shown you the pseudocode I wrote for that. Another one could be the second task, which we are asked to sort 3 numbers. That is this one. So develop an algorithm that reads 3 numbers and write them all in a sorted order. So this is how I wrote this particular one. So I start, then I read the numbers. I'm going to check if A is greater than B. If it is true, then print B, A. I'm also going to check if A is greater than C, because it's supposed to be a loop. If A is greater than C, then print CA. Then I'm going to check if B is greater than C. If that is true, I'm going to print CB. Now if you check, all the results I'm getting, the values I have get inverse. That is because I am saying that it is true. So if it is false, then it is the other way around. So since A is greater than B, it means that in ascending order, B comes before A. And since A is greater than C, in ascending order, C will come before A. And since B is greater than C, it means that in ascending order, C will come before B. Now, to display this in ascending order, because we are reading 3 numbers, not 4 numbers or 5 numbers or 6, we are reading 3. So how are you going to arrange these 3? So let's start. When we were doing our loop, we got the result that A is greater than B. And we also got another result that A is greater than C. So it means that A is the largest number in that series. So A goes to the last position because we are doing it in ascending order. Then the next thing was, we noticed that A was greater than B and B was greater than C. So it means that C is the smallest in the series. So C occupies the first position, and automatically B gets into the middle because B is greater than C but less than A. So that is how I've written the pseudocode here. If you want, you can add another step here after this particular point here and just do sort. Okay, so over here you can write the sort function to now display, and the display is the final result here. So for me, I didn't remember to put sort here, so you can put that. That should be your next step before the display, and then you end your program. So now let's look at the flow chart for that. Okay, we can sort 3 flow charts. Good. So this one is a little large, so I don't need to really zoom that much into it. So we start and then we declare our numbers A, B, C. These are just examples. So if A is greater than B? If true, then print BA. A greater than C, if true, print CA. If B greater than C, if true, print CB. So the result now is going to be sorted according to ascending order, so from the smallest to the largest. And we see that A is greater than C and B is greater than C, so C takes the first spot. Then A is greater than B, so B takes, and B is greater than C, so B takes the next spot, and then A takes the last spot because it is the largest in the series. Then you can end your program. So that is just how you do this particular one. That is the flow diagram for it. Then the final one is to calculate a random sum, and then when you hit a negative value, the program breaks, then prints the results out. So let's see, we start, then we initialize x to 0. I want to initialize x to 0. Now I'll ask the user to input a value. So for example, if the user inputs 2, I'm going to check if x will be equal to x plus y. If x plus y returns a negative value, then I am going to print the result. So let's say 0 plus 2, we are not getting a negative value. So we move on to the next step. Else, repeat steps 2 to 4 till you hit a negative value and print result. So here, 1, 2, 3. That is so it should rather be step 3, 4, 5, not step 2 to 4. Step 3, 4, 5 to check if you hit the negative value, then you print the result. So for this one, you keep on entering the values. So when you do it, so from here, you see that you get a new value for x. Then let's say it returns a positive value. It means you have to come back again and ask the user for input with this new value, which is 2. X is now 2 and no longer 0. So the value for x will keep changing until, let's say, you input a negative number. You put you get a negative number. Okay, so then the system, if you get a negative value, the system is going to now print the result for you. So to look at that one too, we can, this is my flow diagram for it. Sorry, so yeah, this is clear. So we start and then we initialize x to 0. Then we ask the user to give an input, and we are going to check the result here. So x is going to get a new value, so x will now be equal to x plus y. Then if it is positive over here, if it is positive, we have to ask the user for another input to input a new value. Then we come down again to check the value for x. Is x plus y, the new value, going to be positive or negative? If it is positive, we have to go back and ask for an input again. But if it is negative, we print the result and end the program. And then right from here, if we get this value to be negative, which is this, we are going to go straight and print the result. So this is how you are going to this is how you think about your programs before you write them into code. That is what pseudocode does. So it gives you an idea of what you are going to work with. Okay, so that is it. If you have any questions about any of the 3 different tasks, you can leave a comment or send me a direct message on Slack, and I can respond to your query. Thank you for watching.